This is Lifeworlds, the place where we explore life through other eyes and minds. Let's flip the script and discover how to orient your world around nature. I'm Alexa Firminish. Come join me as we get down and forage for fungi, stalk coyotes, draft laws for rivers, hum with beehives, sing bird language, and help beavers to dam again. Let these stories spark your reconnection to nature's multiverse. Learn how to bring ecosystems back to life, become an agent for other intelligences, and begin to see how you too are the sum of all life worlds. Good morning, folks. How are you doing? This is your host, Alexa Firminish, coming to you today from a laundry cupboard in Mexico, because that was the only place I could find that didn't echo. So let's hope no one randomly walks in on me today. In this episode, I will be speaking with one of the world's most fascinating data scientists. His name is Dan Hammer, and he's been building some pretty exceptional tools to help support the protection and regeneration of the planet and local communities. His approach, to use the language of this podcast, is to view the life worlds of the Earth through the vantage point of satellites and satellite imagery, combining that with things like machine learning and big data to translate it into information that communities on the ground can actually use. And what you'll see is that the red thread across all of his fascinating roles has been in pioneering the ways that we can convert massive amounts of data, as I mentioned, mostly satellite imagery of the Earth, to make it more accessible for those who need it the most. Very often, in this case, people like journalists and educators who are telling stories from the ground up. Now, I wanted to do an episode on this subject because I've wondered for a long time how these vast new capacities we have for data and computation could shift the ways that we understand our human place on a changing Earth and our place amongst other species. Can we use all of that vision, that knowledge, that intelligent data architecture to become better stewards? I am a firm believer that the more that we can see and know, the more that is made transparent and unavoidable, inexcusable, inescapable, the less we can turn away. And also the more our fascination grows about the Earth. This has been my personal experience as well, observing these patterns and flows that we'll get into in this episode. A little bit about Dan, because his background, I think, is quite useful in painting a picture of where we'll go in the episode. So he is the managing partner at Ode, which is a data and design agency for the environment. And before that, he held a bunch of different roles. Principally, he was the chief data scientist at the World Resources Institute, where he co-founded something you may have heard of called the Global Forest Watch, which is a nonprofit that tracked and monitored global deforestation patterns. He also founded SpaceNo, a satellite image analytics startup, and was senior advisor in the Obama White House and a presidential innovation fellow at NASA. In this episode, we're actually going to touch a bit on his new endeavour, which is attempting to create an open source foundation model for nature. We'll get into exactly what that is, but essentially you can imagine it as a tool to begin querying the landscape or asking questions of the landscape, like you would to something like Google Maps. And their founding team for this initiative has quite the roster. You have the founder and builder of Microsoft's planetary computer, the former head of AI policy in the Obama White House, the former chief of staff to John Kerry, and several other brilliant minds. And let me give you also some examples of how this translation from satellite to action happens, to kind of give you a sense, right, of the range of applications for this type of science. So Dan and his various teams have used direct Earth observation to locate every wastewater pond in rural Alabama, to watch illegal mining unfold in the Amazon, to find every plastic waste site along rivers in Vietnam. He created the application Climate Trace for former Vice President Al Gore, which is the first facility-level global inventory of greenhouse gas emissions, identifying, tracking, monitoring individual sources of emissions across major sectors of the economy, mapping up to 70,000 of the highest emitting greenhouse gas sources down to their source, and then publishing that information within weeks. So think of things like coal mines and power station smokestacks worldwide being made transparent and visible in terms of their impact on the earth. They've also created Amazon Mining Watch for the Blitzer Center, which is using machine learning to map the scars of mining activities in Amazonian countries. So essentially showing where illegal mining is happening and using algorithms to recognize sort of characteristic changes over time in the landscape, which can flag and detect when new mining activity is beginning to happen. They also create something called Global Plastic Watch and a tool called The Margin that empowers local advocates to show exactly where communities are being made invisible in the data that's used to prioritize federal funding for environmental justice. So as you can see, the applications of this kind of work are far-ranging, they're wide, and they have incredibly high impact. And what I've taken away from this discussion with Dan and from my own research is that a lot of the information that we need to make better decisions about human actions and impacts on the earth actually is there, it does exist. But it needs to be translated to be useful for those who need it and for when they need it. So based on that, I'll be asking Dan questions about how he manages to strike this balance between massive global information layers and local relevance, and how he himself toggles between these macro and local perspectives. And, says my own little skeptical mind, is it really possible that a global model, something that is so detached from the ground, can actually help people get closer to their place, to develop a deeper intimacy and more participation in the lands that they reside? Taking this maybe one step further and then handing over to the interview with Dan, at a deeper level, the way I see this, if I kind of zoom out and view this phenomenon and what's being described, it feels to me that we're part of a planet that's learning to see itself. We've created, I know this sounds wacky, but we've created these eyes in the form of satellites and brilliant computation that are looking back at the Earth from space. And if you want to sort of think about consciousness or sentience, which I know are tricky terms, it fascinates me that there's these distributed cells of Earth watching and reporting, allowing the Earth to behold itself and its own life world in a whole new way. So, all that and more today on Lifeworlds. Here is Dan Hammer. Dan Hammer, an amazing name. Welcome to Lifeworld. Welcome to the podcast. How are you doing today?
I'm well. Thank you. Thanks for having me.
Oh, it's such a pleasure to have you here. In the introduction to this episode, I've already queued up a little bit of your work, and I thought that it would be nice to start off with a sort of high-level vision or view of the kind of work that's characterized your life and your career, and then we can get granular into some of the different projects and their utility. And so, if that's okay with you, I'm going to start you off with your own vision statement that you sent me once in a document, right? Which is, you said, your vision is a world that has greater awareness of how the natural environment is changing. And from that awareness, a society that can take informed action, which is obviously incredible. And along those lines, you've co-founded what you call a data and design agency for the environment. I love that it's for the environment, where you convert data about the earth. And often that data is difficult to understand, highly academic, about all of the world's complex ecosystems, using the language of the podcast, all of these nested life worlds. And you and your team translate that into information that people can use or understand. So a lot about this podcast refers to the act of translation. And so let's talk about translation. When you guys first come across this Earth data, what format is it in? What do you come across, and why isn't that very usable or interpretable for the average person?
Well, the data that we start with is barely interpretable by machines, let alone humans. There's just a multitude of different formats. And the most interesting information is some sort of fusion of a bunch of them. And so the idea of just putting them into the same place where a machine could read them, and then a person who can wield those machines can read them is a process in and of itself. So just to pick up the shovel and start putting them together is a task. I graduated from the Berkeley Institute for Data Science. And at the time, and I don't know if this is still the case, I feel sort of old in this tech world now, but 90% of the work was just in data cleaning before you even got to the interesting parts. And so just putting it into formats so that you can find and explore those implicit patterns in the data just takes a heavy lift right now. And I think that's part of what we end up trying to do over and over again is reduce that time between humans and the information that was in that raw data.
So when you come across it, this raw data, I'm, what do you call a plebeian, or what's the right word when you're a sort of commoner? I don't really know. What does it mean when you're coming across this data? Is it imagery? Is it dusty textbooks? I mean, what data are you having to clean and reduce the noise in and find these patterns through?
Well, not a plebeian, just a newcomer, someone who is about to learn. But Earth observation data can take all sorts of forms. It can be audio, it can be imagery, all sorts of sensors and about the natural environment. We end up using almost exclusively, except for some contextual data, direct Earth observation data. So not sort of interpreted by national governments who may have a vested interest in reporting one way or the other, but direct Earth observation data. And our sort of corner of this world ends up being a direct Earth observation from satellite-borne sensors. So not just direct photos like red, green, blue photos that we're used to seeing, but other sorts of sensors to detect infrared, which is correlated with like vegetation density, or sensors to detect persistent and extreme plumes of methane or CO2. But we end up trying to focus on that because it's easier to sort of tune and use algorithms on data where we understand the sort of mechanical transformations as opposed to the human incentive transformations that might be like lying or misleading, which are more difficult to back out. So we end up using direct Earth observation data mainly from satellite-borne sensors that comes in the form of imagery.
I've been reading quite a lot about the different types of satellite information that's going to come online in the next 5, 6, 7 years because of my work with the lab. It's thrilling, right? So the next question I want to ask you, you said, when you're in university, things have changed very quickly. I feel like there is exponential advances in this space. So why is this moment in time quite unique when it comes to what we might expect to see from this Earth observation, let alone the patterns that can be deduced? Like what we'll be able to see in 6 years, from space that we couldn't see today about the Earth?
Oh, man. Well, so I started to have an answer, but that second part really got me. I don't know that I can predict the future, but I do know that there's this confluence of three streams that are exciting here. One is these new machine learning and AI frameworks in order to extract the patterns from existing data. So this is sort of pulling out information on the intensive margin on data. So data that already exists and just getting a deeper understanding of what's in there and making those patterns more accessible to many, many more people. Then there's compute. It's just cheaper, although it doesn't feel cheap often to try to deploy those frameworks against this vast amount of data. It's actually quite expensive, which is why you end up having some, AI nonprofits move into commercial applications, sometimes just to pay for the compute. But it is getting cheaper in order to deploy bigger and bigger models. And then the third is the extensive margin or collection of new data. And some of those data sets that I'm really excited about is our partners at Carbon Mapper are detecting methane plumes, which end up being a big issue, but it's relatively localized. So it feels like something you could do about as opposed to sort of diffuse natural change. The thing I'm most excited about, though, is the first one. And this is the thing that I'm eager to work on. And I'm excited to start to work with some really amazing people on a project to build this foundation model for Earth observation, which is just indexing all of that Earth observation for search by many, many more people in an open and transparent way. And so that I think is the place where we're going to see the most use or sort of major transformations in this space. But it's really hard to predict what people are going to use it for. That's sort of the point of a foundation model. It's this big upfront lift to enable just a wide breadth of downstream applications that we can't predict. And that's sort of the exciting part of building that infrastructure, is because you don't really know how people will use it. But yeah, that's the exciting part for me.
I'm torn between asking about the foundation model now or asking you another thing that was on my mind. I'm going to start with the first one to warm us up, because the foundation model is incredibly thrilling. And this is, out of everything we've discussed prior to this call, the thing that I keep referencing in my mind and thinking about over and over again. So before we go there, it's very interesting because, again, on this podcast, we always speak about like the frames of reference that someone's operating from. Like, what perspective are you sitting in as you look out at the world? So as a data scientist, what I think is fascinating, it seems to me, and correct me if I'm wrong, like in the work that you do, you have to toggle between these two quite different lenses, right? And the first one is, and I don't know if you have to balance these every day or every month in your work, but you sort of have on one hand these massive global information layers, right? These sort of bird's eye view of the Earth. Bird's eye view isn't correct. It would be like a moon-like view or Saturn-like view. I don't know. You're seeing the Earth from space, right? And then you're also designing products and applications for highly local relevance. Like, you're always seeking that, from what I've understood about your work. Like, how is this useful for people on the ground? So how do you, as a person, Dan, toggle between that super macro — I don't think you can get more macro about the Earth — and then local perspective? How do you do that?
Yeah, that's a good question too. I don't know that I have the capacity to switch contexts personally so much, but I do know that some people live in locally. So what that looks like is working alongside local journalists or activists or policymakers that have a very, very specific question for which these sort of global black box models, these sort of force-fed global data sets, don't seem to work just yet, but need to be finely tuned in order to suit their particular, very highly resolved question. And by highly resolved, I mean like local question, both in terms of time and space. So a particular area at a particular time, but also resolved in terms of scope. Like, it's not deforestation, which is a fairly broad concept, but rather deforestation that had this particular pattern with this particular blue tarp, something that they can use, where if I'm sitting like I do behind a computer in my office, I can't know what is relevant, but they can tell me very, very quickly what's relevant.
Is there an example? Maybe you can use the deforestation blue tarp one or another one where you guys were seeing something from the Earth observations, kind of satellite level, and you were just like, what is this? What is going on? Like, we're seeing this pattern from this perspective. And then when you got local, or when you found the right partners on the ground, the interpretation or what was happening on the ground was maybe incredibly surprising or unexpected. Do you have some examples of that?
I mean, there's so much change on the Earth's surface that it's really hard to be struck by that there's a unique type of change. Like, we don't even know what is surprising. It's just changing and in flux all the time.
Mm.
But there's a great example done by my co-founder and colleague, Ed Boyda. He had worked on a project with local journalists for Reuters investigations on the Uyghur detention centers in northern China. And these very large facilities, and honestly, I'm not sure what the status of these facilities are, but in April of 2017, the Chinese government said they were not building these, quote, re-education centers for the Muslim minority in northern China and around Xinjiang. And Ed worked with local journalists to be able to track and analyze the footprints of these large buildings in the deserts. And when you look at them from space, they just look like development in the desert, right? You don't sort of understand that there are up to 1 million Uyghur people that were being detained in these facilities. And you can't see that from space. You can't see gender inequality from space. You can't see income vulnerability from space, but you can see these sort of breadcrumbs. And it takes a lot to be able to interpret a lot of like on the ground reporting, which people do. Like right now, people do. They don't need us. We can just help them provide that sort of overall view or catalog of this change. But to be able to track the footprints, and specifically track the footprints between before or after April 2017, when the Chinese government said they weren't building them, to say, we can see you building them after April 2017, and then to be able to work with journalists to understand why that's so, politically or geopolitically important, or from a humanitarian perspective, so important that they were continuing to build these things. But it does require interpretation that we don't have the capacity to do from our computers.
Another sort of personal question, and then I'll move us back into like some of the examples. Does it ever get frustrating, or do you ever feel kind of impotent? Because it happens to me with some of the mapping that we're doing in the ecology lab where I work, that you can see these. So for example, these detention camps, like imagine you're watching, right, this spread, and it's not an image on a screen. You know that is real humans living in probably very squalid and painful conditions, and you're seeing a spreader. After this, I want to speak about your time with Global Forest Watch, but let's say you're watching the deforestation happen, and you know that that's a terrible thing that's occurring, and you're watching the pattern, but I don't want to say that you're abstracted, but you're several layers removed because you're sort of watching it happen. So how does it feel to view the world from that perspective and watch these patterns unfold without necessarily being there on the ground working in them?
Well, I don't know how it's affecting me personally. I'm worried though, because we have two colleagues that have had to take a break because it's like reading the front page of the newspaper all the time, every day. And that's not usually a uplifting experience.
Yeah, I can understand that. And actually, the analogy or the example you drew of people who just read the front page of the news, you're right. It's not actually so dissimilar to what you're observing. It's massive issues happening elsewhere that you're reading about that you want to be involved in some way, but also several layers removed. And I think that we are awash with information today. And then to understand where we can act on it is the key part. So let's talk a little bit about Global Forest Watch. I'm really curious from that experience what you and your colleagues learned about what works, maybe what doesn't work in data design and communication for the earth or for the environment, as you say. So just to remind the listeners, I said in the intro, but you were the chief data scientist at the World Resources Institute, which has been ranked as one of the top environmental think tanks in the world. And while you were there, you and some others co-founded the Global Forest Watch, its first versions, to monitor deforestation from satellites imagery. So yeah, maybe you can speak a little bit about what you learned in that role in terms of what works and what doesn't in that design and communication of the data.
We had Google Analytics installed on that site from the very beginning. And so we could track who was using the site, where they came from and why they got there, basically. And over the course of the first couple of years, there was a steady beat of around 1,500 to 2,000 people coming every day to the site. But that steady beat was punctuated by these massive spikes in usage when a journalist used the data in the service of reporting on an environmental or humanitarian event. So we could, watch that steady beat of 1,500, 2,000 people spike to 20, 30, 40,000 people in a day when there was a story about, illegal deforestation in the Amazon or broad trends in Southeast Asia, some way to contextualize those pixels, because the Global Forest Watch deforestation pops up as pink pixels on this sort of green landscape. But not all pink pixels were created equally. Sometimes they were timber extraction from a seasonal eucalyptus plantation or a palm oil plantation, for example. But sometimes it was illegal deforestation or illegal mining in the Yanomami territory of the Amazon, for example. And those are two very different types of economic and behavior with all sorts of different implications for environmental or economic justice. And so it's the people who could actually interpret that change and be able to tell the story behind it that were so important. And so basically after that point, and the reason why we ended up spending so much time with environmental journalists or just journalists in general after leaving the World Resources Institute was just to try to operationalize those spikes. So to give journalists, people who can tell those stories and report on those events, better access to the tools in order to tell them with compelling, credible, and globally consistent information.
And do you find that other organizations saw the success of something like that and then replicated it? I mean, you seems like you also replicated, Global Plastic Watch, et cetera, in other projects. Would you say it sort of created more awareness that there are these ways of understanding the earth that can be highly useful for global awareness, local action, so on and so forth? Like, was it one of the first kind of waves of that?
I think it was definitely part of that wave. And I think it was an early application in that wave. I don't know that Global Forest Watch had, I wouldn't even say it paved any way, but it did represent this new world of just better information access and a place where we were able to process that information better. Like when we started Global Forest Watch, we were an early user of Amazon Web Services, which was the ability to process a lot more information from your laptop or your desktop, as opposed to trying to organize server time on your university computers or something. Like you could just, pay 24 cents and get an hour of someone else's computer somewhere in the world. But that wasn't Global Forest Watch. We just happened to use those new tools. And so a lot of this work would have happened and did happen. And I think Global Forest Watch was an early application, but it was going to happen anyway. That tide had sort of shifted. And I keep coming back to it, but I do think that we're at the beginning of a new sort of wave. So there was this cloud compute early on for environmental monitoring, and we're at this new early wave where there's going to be a lot of applications. Every day you can see one in the news now around Earth observation and some of the technologies that have been created in the last few months through this generative AI frenzy. So it does feel very similar to around, 2012.
So let's get into that now, the foundation model stuff. You've sort of called these open source foundation models for nature. You've said, you can start to query the landscape like you would Google Maps. You can start to ask questions of a landscape. So just back to the basics for a teenager or someone who's just starting to learn what this is. What is a foundation model? Use whatever simple metaphors can be found. And why is it so transformational? Why is this like as you were saying, a new phase, specifically in your line of work?
It's a very broad term. And the way in which we use it is that it's basically the heavy lift of organizing information that can be finely tuned and reassembled for quick applications downstream. So, for example, when we did Global Plastic Watch to identify plastics from satellite imagery, a lot of that sort of heavy lift that, remember, I made reference early on to that 90% of the work to get just to start the study. A lot of that work, that sort of picking up a shovel and moving data around, is the same. And there are projects that help put data in the same format, which gets you, maybe 40% of the way there. And that's been worked on for a really long time. And so the next 40% to 50 to even 59% to get most of the way there needs to be not just organizing the bits and bytes, but actually organizing the patterns in a way that people can start to interact with in a sort of a more meaningful way. And so a foundation model for us is a way in which to extract those patterns and store them in a way that can be recalled through a web platform. So this also feels a lot like Global Forest Watch in the sense that these models now exist out there and they're being created all the time by researchers and academics out of the Allen Institute for AI or Berkeley or Stanford. These models exist out there, but just because they exist doesn't mean that people can interact with them in a meaningful way. Like we hear sort of this amazing work from IBM and NASA being able to do these foundation models on Earth observation. But there's this gap between that and having a local journalist reporting on artisanal mining in the Amazon be able to actually leverage that power. And part of what it means to leverage it is to have confidence that you're using sharp tools, basically. So this project that I'm working on with, among others, but led by Bruno, who built Microsoft's planetary computer, is to build that interface and organize the models, these new and emerging foundation models, in a way that can be interacted with and benchmarked in this open and transparent way. So very similar to Global Forest Watch in the sense that this stuff exists out there. It's just really hard to access for data scientists or professionals, let alone the people who could actually use it to affect some sort of change to tell that story.
Yeah, it's super cool. I remember in one of our first calls, you showed me a simulation. You shared a screen with me and you showed me how a foundation model could, the sort of, let's say, the transformation here based on what existed before was that you can find things quickly and then discern that pattern and then scale it out across a landscape. So some of the examples you gave were illegal airstrips in the Amazon or environmental crimes, mining, timber extraction, etc. Maybe you can give like two examples, like visually, of how this foundation model could be used in a geography. Like if I was on my computer, what could I acquire into? What could I ask to see?
Yeah, no, that's a really good question because I get lost in sort of the technicalities, but it feels different. There is like this seismic shift when you can actually engage with the information. Like it's hard to even imagine what that would look like. And so to hear about those applications actually does resonate right now. I think that's part of it, is just to sort of show the art of the possible here and to release it. And so in this sort of functional toy that we had built, some of the applications include like finding plastic waste sites. So for example, in Bali, in Indonesia, we started with this data set of the locations of 10 plastic waste sites. So we knew where some of these plastic waste sites are. They're like large scale dumps that you can see from Google Earth and even Street View. You can sort of see these mounds of plastic. So we knew where 10 of them were. And the question is, or the early question was, can we find all of the dumps in Indonesia? There were sort of conflicting and inconsistent reports of locations of these plastic dump sites. And then from the government. So when we went through and started to look for them from imagery, just to validate that they were there, or Street View, a lot of them were either out of date or just sort of misplaced, for example. And what's worse is that there were a lot of false negatives. That is, there was a lot of areas of this plastic waste that we could sort of see for ourselves and along partners that wasn't listed in these official databases. So we started with those 10, and these sites have a particular character over space and time. It looks different than the other landscape, and it changes differently from the other landscape. So there are these temporal and spatial patterns that are unique to this particular land use. And this one's a fairly easy one. Deforestation and plastics are fairly easy. Sometimes they're much more subtle patterns here, which we'll get to in a second. But if we could use some of these new large models in order to distill that stack of imagery, so repeated images over time, into a sequence, like a vector sequence of numbers, where those numbers represent some impulse along like a neural network, or something got ticked off along the way in a certain pattern, and you're distilling this into its distinct essence, then you can start to search through these vector databases in order to find other things that are just like it. And the better that sequence is at characterizing the essence of that stack, the easier it is to find other things like it. So we started with those 10, and we were able to go from island to island in order to collect and verify many, many more. I think there are up to 391 of these sites in Indonesia alone. This isn't a global model. This wasn't like a custom-built, trained model in order to identify plastic waste sites globally, because plastic waste sites look totally different in Saudi Arabia than they do in Indonesia. But it's this bootstrapping of the data, this cataloging of the information outward from things that you knew, that you were sure of, those 10 sites in Bali, in order to find other things like it and start to assemble that data set that you could use. Now it's global, right? So we had these sort of seeds of where we knew that there were some sites, and we can sort of go outward in order to create a global data set, but from the ground up as opposed from the top down. Another more subtle pattern is like confined animal feeding operations in Alabama or in Brazil, like the Tapajós Basin in Brazil. It's where we raise cattle, and what that looks like is totally different. Like a confined animal feeding operation in Alabama looks like these long set of 4 or 5 parallel sets of these long tin buildings. That is not what it looks like in Brazil, where they fence off a portion of the Amazon and let the cows run roughshod until it looks like grazing land. And for that, it's much more difficult to distinguish those CAFOs, or confined animal feeding operations, from the other parts of the landscape. It requires a little bit more interaction to help a person, an expert in this field, or a policymaker in this field, or an activist in this field, hone in on that type of image, that little bit of variation that they actually care about. And it's an interface. It's about giving sort of the tools to say, well, actually, artificial intelligence, what you've just surfaced to me is not a CAFO. It's a golf course. I need to sort of like find my way to the cluster of information that I care about. And that really is more about a user interface and user experience question than a technology question. But you're navigating through the results of this technology. So it's a cool new field in order to find things that you know are there. You just need to figure out a way in which to collect them efficiently and easily.
It's so interesting. So do you imagine that I could be a person in a landscape, and at some point in time, I could go onto this foundation model website and either say, hey, this is what a plastic dump site or an illegal mining strip looks like in my geography. And I know that because I live above it. And so I've taken a screenshot from the sky. Can you find more of these? And so are you imagining that me as an average person in that landscape could ask this interface these questions? It would spit back some information, and obviously anything I input can be used by anyone else. So the model is also learning from me as a person in the landscape as I'm tweaking it and telling it like, hey, no, this actually isn't coral or whatever. Are you imagining that I could converse in that way? Because I'm just mentioning because you gave the GPT-3 example.
I think so. I like the word converse, or to be a little bit more fluent in these changes on the landscape. But yes, I know about my local neighborhood right now. I mean, the way in which I will use this in sort of the most mundane sort of way, and the way in which we'll know that it's good enough is I live in the city of Berkeley, and the city of Berkeley has gone through over the past 4 years sort of renovating playgrounds. I have a 2 and a 6-year-old, so we frequent playgrounds all the time. And I know that my local one, a block and a half away, was renovated 2 years ago, for example. And I just wanted to know where the playgrounds were that had recently been renovated. So I know where one is, and it has a particular signature. You can see this stuff from satellite imagery. If I really spent a long time on Google Earth, I could answer this question right now. It would take a while, maybe like a half hour of pouring through images, but I could do it. I could figure it out. If that information was in HTML pages, like on the cityofberkeley.info's site, then Google would have already done that for me, would have indexed for search. So I could type into Google, where are the most recently renovated playgrounds in Berkeley? Unfortunately, it's not in HTML pages. It's not on city websites in a way that I can tell from Googling. That information does exist. That data has already been collected. It's just sitting in images. It just hasn't been sort of liberated for this type of search. So the idea is, yes, like I could go, and it might not be a text interface, for example, for a while. There might be some sort of semantic mapping down the line, but I know where this is. So I would click on that playground and say, show me everything that has changed on the landscape in this particular way over this particular time frame, and put it on a map for me. When I can find those newly renovated playgrounds in Berkeley for myself, then I'll know that this is useful. That'll be my metric.
I love that, playgrounds. Okay, this is going to sound a bit esoteric, but it just came to mind as you were sharing the examples before, so bear with me. I did an episode a few episodes ago. Actually, I've done 2 episodes on this, but sort of tracking both wildlife trackers, let's say, as human beings were tracking. I actually was in Romania tracking bison, but that's another story. And so tracking, 2 things kind of come up. For me, I feel like what you're describing, and I'm just trying to give another metaphor, is you're training these algorithms or these networks, neural networks, to sort of become like trackers, either animal trackers or human trackers that are learning how to read signs across a landscape. So either it's like in the case of playgrounds, you like give your hound dog the smell of the animal is tracking and you're like, yo, go find the truffles or go find the hare, or give it something to smell, and then it just goes and finds it. Or as a human tracker, you become trained in these skills of understanding that a notch in a tree in Alabama is not the same thing as a notch in a tree in Kenya, and they both have very different unique signatures. But it's fascinating that we're creating these artificial intelligences and we're training them to explore the land from space in the same way that we do physically inside the forest, inside the land. It's a similar process of very local pattern recognition across scales. It's very cool.
I actually really like that analogy. I think that the difference here between what was available to us like 4 years ago and now is that we would have to deeply train and spend a lot of time with a particular set of pigs and dogs in France, for example, right? Like we would spend months and months and months training for a particular signal and teaching the scent of truffles, for example. And now what we're doing, and it's a little bit of scary vision actually, is like training this like generic pack of mechanical dogs. It's starting to feel like the Matrix or something like that.
Okay, it's getting dystopian really quickly.
I know. Quick. And maybe that's worth spending some time on, but where a local person can sort of give a scent for a particular, very subtle scent, right, that they're looking for. And that generic machine can find that scent very, very quickly. So it's not training this sort of custom, like deep learning model or this particular set of pigs or dogs, but it's building the facility, this sort of like artificial nose, basically, in order to find those subtle scents quickly across the world and across context. And I'm sort of like glossing over some of the, I would say, even ethical or legal or the downstream implications of having that power. It is worth spending some time on at some point, and I'm not the person to do it, about like, what does it look like when you can sort of unleash this power onto the rest of the world, is what the responsibilities are. It is very powerful.
All right. So you've got your like demonic pack of like robots, hound dogs being unleashed across the Earth's surface. So I just finished reading a dystopian book, and there is actually a robotic hound dog in it. So I'm imagining what could go wrong is the same that just goes wrong with any amount of more information. It's not exactly maps onto the paperclip maximizer thing, but it's a little bit of that. It's new satellites help groups like Stand.Earth see where all the old growth deforestation is happening. It also helps the forest companies find where all of the oldest biomass trees are. And so it's like anything in AI, it's this race to the bottom where it's essentially the model's going to be built and everyone's going to be able to use it. So we just have to make sure it also gets in the hands of the good guys. I mean, you're saying that you're not going to address the ethical questions, but you're obviously going to have to. And I'm sure that your colleague Bruno, who has this experience with Microsoft and the Pantry computer, has come across some of these things. Maybe you guys discuss this late at night over whiskey, but is there a framework or a place in which those kinds of conversations will happen as relates to this Earth observation data inquiry process?
So this is slightly different, I think, because people who have figured out a way in which to use Earth observation for massive financial gain already have access to this information. These models also exist for the military and extractives and industries. The reason why this is a nonprofit, has to be a nonprofit, I believe, for a long time, is that there is some asymmetry here in the information that has been created by these spaceborne sensors. And so to do so in an open way and to give access to the information in that data in an open way, I think helps to rebalance the power. I think it's a progressive rather than a regressive technology in that way. And just by virtue of existing. I mean, people have won in economics Nobel Prizes for showing the value of symmetric information in the presence of externalities, like environmental externalities, both positive and negative. And there's this deep asymmetry right now in information about the Earth's surface. And you're right, I don't know what the implications are about releasing technology widely, but I do know that the extractives and the military applications right now are available. They're being used right now, but they're just not being used for nature or for positive environmental benefit. I know that there had been grand plans for the release of generative AI for the people who hold the keys to the development to have the social interest at heart. And that went off the rails at some point or wasn't handled particularly well. But a lot of this did start out of nonprofits with that mission, sort of a socially minded mission.
This brings me to think a little bit back to how we started the conversation talking about the people who read the front of the newspaper. We're living in a planet that's basically learning to see itself. We've created these eyes that are looking back at the world. And if you want to talk about consciousness or sentience, it's a very interesting time where we're not just bringing online new forms of intelligences that we've created, but in Buddhism, you have this idea of like, we are consciousness looking back at itself all the time. I'm looking at this flower and this is the flowers looking back at me. In a way, with these satellites, these observations, it's the Earth is beholding itself in a very novel way. And yet, now to bring in E.O. Wilson's quote, we have these Paleolithic instincts, medieval institutions, and godlike technology. And we're still kind of Paleolithic creatures. We are the cavemen we were 10,000 years ago with kind of fancy clothes. And maybe we use cutlery sometimes. So the human mind, it's like when you walk into a supermarket. I remember living in the States and coming out of being in like the few days in the forest, and then you step into like a Walmart and you're just like, oh my God, my monkey brain. There's so much color and choice. It's too much. Can I choose from like 2 shampoos, not 500? It's a bit like the same with information where we get so much information about the state of the earth and so many, you said, news sites, and obviously now there are all the media channels. So what I was going to ask is how much information is too much, but I think the question I actually want to ask is how do we prepare humans to be able to interface with that much information? Because as you say, it's here, it's coming, it's there. And so much of the work that you've done in your career has been about empowering people, right? Empowering people to ask better questions, empowering people to be able to ask back. I remember in one of our first chat, you said, I like that the tool could have follow-up questions, or people can ask many small questions instead of one large monolithic number. So you're obviously thinking about how people ingest information and feel empowered and not disempowered by overwhelm. And back to the front page of the newspaper thing. You may not solve all of the ethical problems of AI, but how are you holding that as you work on all this stuff?
That is a very good. This is mind expanding. This is very interesting to me. And so to take your supermarket example, I thought about the number of popcorn choices at Target. Like that is very overwhelming to me. It's a very simple product, but man, there's a lot of colors and options there. One of the issues with that is there's these bright colors, but how much of the information is hidden in that sort of optionality? Like that is the final manifestation of an incredibly long, complicated, and sometimes very dark process to create those kernels. I think that if people had a little bit more information in a compelling and a credible way about where it comes from and how it got there, you'd have fewer choices and you'd have more local choices, for example. And I think this is the same thing about this information production that we're in. We get this like final data set at the end and we don't know where it came from. And often, and increasingly more so, there will be a black box. Like these are black box models. We don't understand why the machine found certain applications, and there's no way in which to track the provenance back to something that I would trust. And so I think that there is, and this is complicated and I haven't wrapped my head around this. It's just inspired by what you just said, but there is something about being able to offer the tools all the way back to the source of the information in such a way that there is the ethical use of that information is more accessible to many, many more people. I don't think that there's real value right now, at least, and I could be proven wrong tomorrow, but of like generative image AI for Earth observation to create like a new, use that sort of mid-journey which is a generative AI tool to show like the Pope in a puffy jacket. Like, I don't think that there's value to that use of these implicit patterns, these embeddings for the Earth's surface. But I do see the value of being able to shorten the distance between people and the original source of that information. So there's a much more transparent process where the black box is not the point of this exercise, but it just allows you to get to something that you know and can interact with, that you trust. Like I don't trust a lot of these black box models. I don't understand how they were created, and to get a number out the other end is a hard sell. But if that is useful, that number is useful to like going back to the source and generating that information for yourself in a much quicker way, that feels much more compelling and harder to have go totally off the rails towards some unintended and negative consequence. Does that make sense?
Yeah, it does. Give an example of that. What would you like people to ask, or how would you like them to ask for that to be the way it pans out?
Gosh. So Google Earth is really compelling because it is this sort of Earth self-reflection. But there's so much information in there that it's difficult to use productively right now. And I think that the tools that are being developed right now allow for a much more meaningful engagement with that self-reflection, that Earth self-reflection. I think maybe actually spending too much time on the actual technology, and rather than, like, as you had prompted, the ways in which you might use this is part of my problem, actually, is just to express, like, what does it look like to engage with that final vision, that final up-to-date and historical Earth that we can look back on? How would you use that differently in the presence of these tools to help you find what you were actually looking for, a much more meaningful engagement? And I think that that's sort of what I'm excited about, that vision of being able to just ask and answer questions very, very quickly about the Earth's surface. I don't think that that is helped too much. And it is helped a little bit. And it's helped in certain ways by sort of pre-processed data about the Earth's surface, like human modification index, for example. That's a pretty big concept to be able to sort of project on the Earth's surface and then compare across from Bangladesh to Washington State. But if it's useful in sort of wayfinding towards the information that you would need locally, then it is useful. And now I'm just starting spinning out because I haven't quite wrapped my head around this. But I do like the idea of using these tools in order to have more clarity in the whole process of the production of information rather than less.
It strikes me, and I know that we're in the last minutes or so of our allocated time. You and your team and your colleagues, you're at the forefront of some very, very, very powerful tools and way that will shift the global mindset of how we understand our place on Earth and our place amongst other species. And so it's normal, I think, that there aren't clean and cut answers because these questions have never been asked before. And if anything, it strikes me that it might be the co-designing. As you mentioned with Global Forest Watch, it was how those journalists interacted that led you a certain way. And you couldn't have predicted that before. It might be very well the same with this, where some local person in Illinois or in, Bangladesh, as you said, or Switzerland, is going to ask or use the tool or request the visualization. And you're going to be guided by the feedback from the system. And it strikes me that your openness to the question and the receptivity will be what affects how that develops. And it sounds like you're incredibly receptive to that because you are building it, as you said, nonprofit model, but with these end users in mind so that people can ask about their place and understand. And something I always advocate for on this podcast is how do we build deeper relationship to place and deeper intimacy with place? And for me, this is the massive appeal of what you're developing is it could be a really exciting and fun and creative way for people to interact with their place. And sure, yeah, you don't need all the generative, DALL-E 3, Midjourney visualizations, but because maybe that's the way that a teenager will have fun with the data. I don't know what that looks like. I'm not the data scientist like you, but being informed by what people want to use it for, I think that's going to be very exciting to see where that goes in your work.
This is very helpful from just framing my own understanding of what we're doing is to hear it reflected back in these new ways. It's pretty new, so I haven't heard different ways in which to test this framing. And for this sort of intimacy with place is very helpful because, for example, if you go to a new city and you want to find a coffee shop, it probably takes like 5 or 6 small Google queries to find the coffee shop that you would actually walk to from your new hotel, for example. You don't ask Google, where should I go to coffee? I mean, you might, but it ends up being a little bit more of lots of small questions to triangulate against an answer that you would feel trust enough to actually go and walk towards, like take some action. And the idea that we would go and say, hey, NASA, tell me where we should invest resources to protect megafauna. Like, that's not a reasonable question. We don't do that for coffee. We shouldn't be doing that for gorillas. So I think that the idea of using some of this technology in order to become more fluent through these small triangulating questions is actually that's the exciting part. Yeah, it changes the frame.
You don't want to be me trying to find, I've become such a coffee snob that I will look at what's the machine and what shape are they making on top. And if they're making like a swan or like a smiley face with the foam, I'm like, I don't want to go there. Or I judge it. I type in coffee roaster and then it goes there downhill. Lots of image research. Anyway, Dan, thank you so much for the time that you've made to come on the show. It's been such a delight meeting you, and I'm just so excited by what you guys are building and what it's going to enable us to do in terms of protecting and regenerating this earth that we care about.
Well, thank you so much for having me.
So, my friends, that was Dan Hammer here today on Lifeworlds. I wonder, what do you predict? As I said in the start, how could all of this data and computation shift how we understand our place in a changing earth and amongst others? Maybe, just maybe, we can realize the Earth as one living organism, where phytoplankton bloom in the Antarctic waters and seed over half the clouds that bring rain to your front porch. Maybe we can see that species migrate so much further than we ever expected, and that the damage or regeneration we create in one location will always have a global impact. There were questions raised too here in the episode about ethics, right? Like, what are the ethical implications of having the power of such oversight, and in whose hands? The troubles that plague the rapid ascent of AI touch upon these topics too. How do we guard against the overwhelm and a sense of impotency, and instead find ways to empower humans via these breakthrough technologies? All questions, I know, no easy answers, and I'm sure that you have thoughts on this as well. You know where to find me, so please do reach out. Thank you, as ever, for listening, and I will be back with you in some week's time.